A few years ago, I was invited to Jerusalem to be a keynote speaker for a celebration they had in Hadassah. And when I got there, a gentleman came to me. He said that, you're Jewish, no? I said, no. He said, no, I know. I mean that your mom is Jewish. I said, no, my mom is not Jewish either. He said, your father. I said, no. Grandfather, grandma? I said, no. He said, why they invited you? And then he hugged me. I have had a wonderful time. They have invited me 4 times. And I can tell you it has been one of the best experiences I've ever had. Wonderful people. And really, when it comes to scientific collaborations, it's amazing how science brings people together. We have been working on so many projects with our friends, scientist friends in Israel. Now, our next speaker is Erez Ben Ezra. He's coming from Israel. A few months ago, thanks to 3 young Israelis, spacecraft was launched to go to the moon, and it was private. It was not supported by the government. And I'm so pleased that today we have Erez who has come all the way from Israel to represent this group, and hopefully it's going to be so inspiring for you that if you want something to be done, you do it, then you ask for money. Because quite often many young scientists, they believe that I never did anything because nobody supported me. And I'm telling you that in science, it doesn't work that way. And I'm so glad that you're here. Erez, it's all yours. Thank you.
Hey. Thank you, Doctor. Can you hear me? Okay. Thank you, Doctor, for the warm words, and thank you for inviting me, and for the warm hospitality. How are you all doing? Okay, you tired after the food and everything? Okay, so I'll try to do it light because it's space, it's light. So, my name is Erez. I'm a volunteer in the educational division at Space.il. Space.il was created 8 years ago as a non-profit organization in order to land a private spacecraft on the surface of the moon. Now, the vision was to land a spacecraft, which is a scientific project. But the main goal from the beginning was to inspire kids and young students, high school students and even less, to choose to learn science over other stuff. And why, I will elaborate about it later, but it's very important to me to reflect it as this always was a scientific project together with educational project, and sometimes the education part was even more important than the scientific part. So I will start at the end, or at least at the end of part 1 of our journey. This is the last picture that was taken by the spacecraft. It was exactly a month ago, just before the main engine collapsed and the spacecraft crashed on the surface of the moon. That was the end of part 1, which was 8 years, magnificent years of developing and hoping and education and inspiring kids, but that's only the beginning. So it all began 8 years ago or so when XPRIZE, together with Google, announced a competition with a price of $20 million for a private group that will land a private spacecraft on the surface of the moon, and will do some other stuff like taking pictures, jumping around, taking more pictures. If you know XPRIZE, this is the kind of stuff they do in order to inspire and get private groups to do scientific stuff, not only in space. So those 3 Israeli guys, some of them back then were students or still students, they said, why not? Why not go to the moon? And it was something that they start talking to people and brainstorming, and everybody tell them, no, this is not. I mean, private enterprise in Israel that to get to the moon. We're a strong country, but still, this is way beyond, especially when it comes to funding. It's a lot of money. But they refuse to give up. Almost more than 30 groups all over the world registered to this competition, and till 2 years ago, only 5 of them remained. One of them is Israel, but together with a group from the United States, India, and Japan, and another international group. This was just before XPRIZE and Google terminated the competition. Why they did so? Because they pushed the deadline several times, and they said this is not going to happen. It's none of the groups. We always were somewhere on the top, but they thought none of the group was actually going to accomplish this thing in the time frame that was given. But this, for us, it wasn't, as I said, it wasn't a game of, it wasn't for the competition. It was for this inspiration of young people. So we sat down, we said, listen, we're going on. We're continuing doing that because our goal is different. It's not the price. And again, the price of $20 million is nothing compared to the expenses and the cost of space journey. To elaborate about what we were trying to achieve, you know the term Apollo effect? Some of you do? Okay, so Apollo effect is a known effect in the US when those pictures of the Apollo astronauts on the surface of the moon in 1961 and 69, I said? Yeah, that's the year I was born, by the way. There was a huge increase of students and kids choosing to learn science, mathematics, physics on those years. It was a dramatically change. And we wanted to create in Israel the same change as 10 years ago or 15 years ago in Israel, the trend of kids going to and choosing science over other stuff went down. That means that they preferred go to learn economics and business administration and stuff like in the rest of the world. And as a small country with limited natural resources, we said we need to stop it. We need scientists in order to preserve. So we wanted to create the same effect. We wanted to create images of Israel as a small country to be the fourth country that lands a spacecraft on the surface of the moon after the US, China did it twice already, and Soviet Union back then. We wanted to create these images so kids and school students will see the images and will be inspired to do so. That was, again, the main goal of the whole project. So we had the technological mission together with the educational mission. You know this guy? Yeah? This is my personal story, and this is why 8 years ago, I became part of Space IL. This guy, not the actor, the car, okay? I was influenced by this car. I was 14 back then. I was watching this series over the TV, and actually this is what made me in high school to choose the path of electronics and physics, because I said to myself, I'm going to build this car. This was a cool car, had a cool dashboard. It was speaking, it was GPS systems. It was so cool. It's just driving by itself like auto car. Now, someone else built it so far. Someone else built it, but I built something, other stuff. But this is my personal story, and this is why I was hooked up to the story of Space IL, and I said, listen, I'm going to be there, and I'm going to be not in the engineer division, but in the educational division, which was the largest division at Space IL. So this is my personal story, and I'm jumping a bit ahead talking a bit about the educational mission. We wanted to create inspiration. During this time, these 8 years, we did hundreds and thousands of lectures mainly in Israel, but all over the world in 7 languages. We reached over 1 million kids. We actually know exactly which kids we reach by the name, so we know that that's the correct number. And we developed special program about space and other scientific fields. We developed it, and together with the Ministry of Education in Israel, we actually implemented it inside the daily studies at schools. And in some cases, we integrated the work of the scientists with students in high school. For instance, one of our teams developed the algorithm that actually decide where the spacecraft will land. It's an algorithm that takes pictures and observe and identify obstacles. So during the auto landing of the spacecraft, this wasn't manually handled from Earth. It can't be done. So it detects obstacles and actually maneuver the spacecraft so it will land safely. And this was developed with high school kids together with professors in the university. So it was an integration of kids and science. The challenges of the scientific mission. So space is hard, a lot of challenges. A lot of the stuff or challenges were solved or made before, but in our case, because the spacecraft, and I will get into details later, the spacecraft was very small. It's no big than a large washing machine. This is it. This is what we have. Because of lack of money, because lack of resources, we had to do it as small as possible and to save fuel as much as possible. I will get into it later. So it's small, but everything is hard. In our case, we had some challenges that almost no one or no company met before. For instance, the rotation of the spacecraft, because the spacecraft is very small, and most of it is a fuel tank. Actually, it's like a flying fuel tank. So every time the engine accelerates and then stops, the waves of the fuel inside the tank, because it's small and because the vehicle is so small, it's influenced the stability of the spacecraft and its navigation. So it's something that no one tried to solve before, and our engineers needs to actually go to the drawing board and solve this problem, because otherwise it won't work. Just won't work, because it actually was a problem. So this is one problem that we had to solve by ourselves and not like copy-paste from NASA, for instance. Another obstacle was the extreme temperature over a short length of metal, for instance. You don't get it in other spacecraft or space vehicles when in one side you have a burning engine with a high temperature, and in the other side you have the coldness of the space over a period of, 2 meters or even less. So the influence on the metal and on the computers inside is huge. This is something that we needed to solve ourselves. Nobody did it before. So this was an example of something that Israel needed, or not Israel, but this private group needed to solve. Blind landing. I mentioned it before. You cannot control this landing from Earth. You just can't. You need, in some point of time, you need to let the spacecraft go and let it land by itself. Algorithm, engines, everything. You can do nothing. So this is was something that wasn't in the way we did it, was never done before, and we needed to develop it ourselves. Very low redundancy, and another obstacle was to do it accessible to students, because you can do like a NASA project and the kids won't understand what's going on. So one of the goals was whatever you do, you need to do it so simple so it will be accessible to students. Otherwise, we're not reaching our goals. And the main thing for some of our members, the ridiculous budget on it. At first, we thought $30 million would be enough. We end up with almost $100 million. But then again, $100 million in space terms is nothing. It's like NASA going to buying a soda at 7-Eleven. It's almost no money to work with at the beginning. And the goal is very complicated and need to be tested and again. So our three guys, going back to the story, our three guys went to the drawing board, brainstorming with companies, brainstorming with engineers, trying to to raise money, the first money. Actually, I've met them before the register for the competition, and the registration fee was $50,000, which they didn't have. This is where they met me, and I tried to help them. At the last minute, they raised the money, $50,000. That's it. So, and after 8 years, less than 8 years, and after a lot of development, this is more or less the spacecraft that was created. The name is Bereshit. Bereshit is the Hebrew word for Genesis. Actually, the name was crowdsourced as well. I mean, kids actually chose it over the internet. It was like crowdsourced around the name. And these are some, I don't want to get into too much specifics, but these are more or less the interesting data about the spacecraft. The computing ability is not more than a smartphone, just because you don't need more than that in order to perform the task. Most of the weight is fuel, as you see. Like 70 or 80% of the spacecraft is fuel. As I told you, it's like a flying fuel tank, not more than that. 5 feet high, 6 feet wide. It's very, very small. We launched it on SpaceX Falcon 7. Probably know this company, and it had one main engine and other 8 small jets just to stabilize it and help in navigation. Navigation system, we had 3. I will elaborate about it later. Auto landing system, as I mentioned, 7 cameras, and 1 scientific test. I will elaborate about it later as well. You see, this is actually how a picture of the spacecraft, not very sexy. Looks like, I don't know, a dump, I don't know. But this is actually a very important photo because it demonstrates that because of the low budget and because we were very focused on the mission, very focused on education and putting the flag on Israel on the surface of the moon. So you don't have any extras here. You have exactly what you want. You don't have any fancy panels. You don't have any fancy cameras. Everything is very small. Everything is attached to one another, not like a Hollywood style. So this is how it looked like. A lot of tests. You see, this, for instance, this is a test that was supposed to test the landing gears, the extractable landing gears. We did this test in I don't know, just a factory that you have outside any town. We didn't have any facility to do it, just renting some place with the sand and just starting and doing our tests. We didn't have any money to invest in fancy facilities as NASA or others. And you see here the extracting gear was one of our development that actually we filed patents for because it was very advanced, and other companies in the area of space want to use it, so this is one technical achievement. I've mentioned that there was one scientific experiment on board the spacecraft, and this was done because NASA wanted to use our landing and afterwards when the spacecraft on the surface of the moon to measure the magnetic field of objects on the surface of the moon. Initially, we didn't design the spacecraft to do any scientific work, but eventually we agreed because NASA, in exchange, gave us then access to the communication links all over the world. And this solved us actually a huge problem of communication, because when using NASA's communication centers all over the world, we can be in touch with the spacecraft almost 24/7. We almost never losing touch or communication with it. So it was a huge benefit for us. So in exchange, we agreed to put their test or the system on board. It was very small. It didn't bother us. And again, if just in a few words, the moon doesn't have a magnetic field like Earth. It doesn't have, but some obstacles on it, like rocks, big rocks, do have magnetic field. And this is like a mystery for NASA, trying to solve it for years, and we wanted to help as well. So we're starting our journey. This started in last February. We were launched on February on a board of Falcon 7, as I said, and we were hitchhikers. That means that the main mission of this missile was communication center for a European country. I don't remember, sorry. And we were hitchhikers, like a small dot inside the Falcon. The mission itself cost $100 million, and we bought a ticket on a bus for, I don't know, $10 million just to get that there. And this actually was very non-expensive, but the disadvantage of this kind of solution is that you don't choose the date. And this is very important in space. You need to know where, you need to decide you want to be the one that decides when you're going to be in space, to start your journey to the moon or to other planets. And in this case, we didn't have this benefit. We just needed to, okay, we're hitchhiking, whatever date will give us, we'll manage. So this was awesome. The launch went okay. And this is a scary, it's not a picture, it's a drawing, but this was a scary moment. This is where you disconnect from the Falcon, you're all alone, okay, this is your team now. Nobody can help you. It was a scary moment. And then what happened is that we extracted the landing gears and fired up the engine and clapped. And now for the journey itself, because you don't have a huge engine and you don't have fuel, you use gravity. You need to use gravity as much as you can in order to save fuel. By the way, most of the fuel is for, who can guess, for which part of the journey? Landing. Most of the fuel, like 80% or 70% or 50%, that depend, it's for the burn for the landing to stop the spacecraft from crashing. So you need to save all this fuel. So we use gravity. That means that you start orbiting around the Earth, and you fire up your engine for a short period of time and getting the craft to a higher and higher orbit all the time. This took like 50 days. You know how long it took the Apollo to reach the moon? 3 days. 3 days. So this took like 50 days because you again and again use the gravity like a slingshot, again and again. And you see in some parts this is not correct, but in some parts you reach the moon, but then you need to go back the whole way back in order to make a better or higher circle. And at the end, you hope that the moon gravity will catch you. And then you fire up your engine again and start orbiting around the moon. It took like 50 days. This is the longest ever take to any object to reach the moon. Navigation system, and this is a nice story because we used on board 3 navigation systems. One was using the sun, the location of the sun at the sky. The other used stars, like looking at the stars and measuring your position. And the third one was using gravity and the gravity that on the spacecraft. Now, from day one, the star tracker failed. I mean, we noticed that from day one after the launch, this has failed. It was working partially. We could use it a bit, but not entirely as we wanted. And the other system compensated on that, and actually there were no navigation problem. So this was a good call, and this was the only redundancy that was made on the spacecraft. Now, we were supposed to land on the north of the moon, and again, this is a nice story because the location of the landing was evaluated again and again and again. In this case, it was done by a professor in the university, but together with students and high school students. They are like geological research on the moon, and they analyzed the area and decided, actually the kids decided where the spacecraft will land. 50 days of celebration in Israel, since the launch and till the end, talk shows, events, schools. The country was like in a huge celebration. Students were waiting, talking about it, internet, Facebook, everything was, it was very dramatic for Israel. And it was very dramatic as well because it wasn't done by it wasn't created by the government, or it was like private. This was a good thing. So kids were totally all in this celebration. And this is actually the main screen from the mission control. And why this is interesting, because you remember how mission control looks in NASA, for instance? It's a lot of numbers. You don't really understand what's going on. And somebody don't want to explain to you. You want to understand a lot of numbers. Maybe you see the spacecraft where it is, but because we wanted it to be during the mission accessible for kids, the team created a very simple board, very simple few indicators like height, like position and velocity. And here you see the eight engines as the picture was taken from down. You see the main one. You see the main one at the middle, and then another 8 small ones in order to adjust. And when an engine was fired up, it turns green. So even small kids can understand what's happening with the spacecraft because we don't have streaming, we don't have a real image, but I sat with a lot of kids during the event, and they actually understood what's going on with the spacecraft. So this was very interesting to see that they actually knew, and this was proven a correct way to present it. Missing one. Okay, let's jump to here. This photo was taken during the descent, the beginning of the descent. This is the closest image that we got that is close to what we wanted to achieve. The flag of Israel with the moon. This was when actually the spacecraft started the descent. And what happened now? At a height of 20 kilometers, the spacecraft started as scheduled to descend. The main engine was fired up, helping the spacecraft to slow down, and then started to descend. The plan was that it will descend to the height of 5 meters or so. It's like, I don't know, the ceiling or so, 5 meters, and then cut down the engine, and then the spacecraft was supposed to slowly crash. it's not a crash, but slowly descend. And this is why we needed to develop, as I said, very specific landing gears to be able to absorb the heat. What happened actually is at a height of 15 kilometers or so, the engine received wrong command from the computer, from the CPU. Again, it wasn't manually, it was all automatically. And it was a human error in coding. So the engine stopped at the height of 15 kilometers, and then the spacecraft started to crash, to accelerate actually. And the engine actually had a system that made him fired up again. We learned about it later. It actually detected the problem and fired up the engine, but it was too late. It was too late. So it was a magnificent crash on the surface of the moon. And this is the last picture that was taken. This always was alive. I mean, the picture, the photos were taken, and we saw it live on the TV or over the internet. And that's it. And that's it. More interesting fact about what I just told you about. We weren't the fourth country to land on the surface of the moon, but we were one of the 7 countries to orbit around the moon, which is nice. It's a nice goal. It is the smallest spacecraft by weight that ever reached there. It was developed. It's almost an investment of $100 million. By the way, most of the money came, like $40 million out of it from wealthy Jewish, Israeli people. The rest, some of it was given by the state of Israel. I don't know, 5% out of it, which is nothing. And the rest actually from companies, organization, and even crowdfunding when kids and students donated like $1, $2, just to be able to be part of it. It was very, very nice thing that happened, and we raised $100 million, which is nice. It was very nice. SpaceIL has only 30 employees. It's nothing. Most of the personnel at SpaceIL are people like me, volunteers that spreading the words, giving lectures, going to schools, participating in workshops. The spacecraft made the longest journey until landing on the moon. That's the spacecraft that was supposed to get to the moon that made the longest journey. Okay, there's a confusion. Oh, sorry, that's me. Other achievement, Apollo effect, or now we call it Bereshit effect, because there is an effect. So we don't have a number yet, but we reached, as I said, 1 million students and more. We know for sure that there was a huge increase in students that are choosing to go to learn science. When I say science, it's not only mathematics and physics. It's medicine, medical, all kinds of. We're not only focusing on space, but other areas as well of science. What else? Several patents, as I said, for the landing gear especially. Several contracts were signed. Actually, in Europe, for instance, two companies from the field of space actually signed a contract with SpaceIL in order to utilize all the knowledge and ability, because they want to develop unmanned shuttles to the moon for numerous tasks. So this knowledge won't go to waste, and even maybe will bring some money into SpaceIL to accomplish more tasks. Within 3 days from the crash, SpaceIL announced Bereshit 2, and a month later, which is today, we already back to the drawing board, and we know we have like a plan, and the first donation came in, huge amount of money, because the inspiration worked and people want to see the continue of this project. So this is a great news for us, and probably in 3 or 4 years we'll have Bereshit 2 hopefully landing on the moon. It will be less expensive because we have most of the know-how. We need to correct ourselves still, but we have more of the know-how. It will be less expensive, and it won't take 8 years. These are the 3 guys which I adore. And I believe we have a question session later. So thank you very much for having me. I hope you enjoyed it. Thank you.